A war has been raging for billions of years, killing trillions every single day, while we don't even notice. This war involves the single deadliest being on our planet, the bacteriophage. Even bacteria can get a virus. The viruses that infect bacteria are called bacteriophages, and certain bacteriophages have been studied in detail in the lab, making them some of the viruses we understand best. Characteristics of bacteriophages. Thousands of varieties of phage exist, each of which may infect only one type or a few types of bacteria or archaea. Phages are classified in a number of virus families. Some examples include Inviridae, Microviridae, Rudiviridae, and Tectiviridae. Like all viruses, phages are simple organisms that consist of a core of genetic material, nucleic acid, surrounded by a protein capsid. The nucleic acid may be either DNA or RNA and may be double-stranded or single-stranded. There are three basic structural forms of phage: an icosahedral, 20-sided, head with a tail, an icosahedral head without a tail, and a filamentous form. A bacteriophage, or phage for short, is a virus that infects bacteria. Like other types of viruses, bacteriophages vary a lot in their shape and genetic material. Phage genomes can consist of either DNA or RNA, and can contain as few as 4 genes or as many as several hundred. The capsid of a bacteriophage can be icosahedral, filamentous, or head-tail in shape. The head-tail structure seems to be unique to phages and their close relatives, and is not found in eukaryotic viruses. Bacteriophage infections. Bacteriophages, just like other viruses, must infect a host cell in order to reproduce. The steps that make up the infection process are collectively called the life cycle of the phage. Some phages can only reproduce via a lytic life cycle, in which they burst and kill their host cells. Other phages can alternate between a lytic life cycle and a lysogenic life cycle, in which they don't kill the host cell, and are instead copied along with the host DNA each time the cell divides. Bacteriophage versus antibiotics. Before antibiotics were discovered, there was considerable research on bacteriophages as a treatment for human bacterial diseases. Bacteriophages attack only their host bacteria, not human cells, so they are potentially good candidates to treat bacterial diseases in humans. After antibiotics were discovered, the phage approach was largely abandoned in many parts of the world, particularly English-speaking countries. However, phages continued to be used for medical purposes in a number of countries, including Russia, Georgia, and Poland, where they remain in use today. There is increasing interest in bringing back the phage approach elsewhere, as antibiotic-resistant bacteria become more and more of a problem. Research is still needed to see how safe and effective phages are, but who knows? One day, your doctor might write you a prescription for phages instead of penicillin.